In this video sequence, we're going to deal with this methanoic acid cell question. So it says methanoic acid in the presence of a catalyst can be used to produce electricity in a fuel cell as represented by the following diagram. These sorts of diagrams are really helpful to challenge yourself with because they commonly show up on the diploma. This particular cell has got the anode, and it's a fuel cell. Fuel cells just keep pumping in the fuel. So their fuel here is methanoic acid and oxygen. Now, hydrogen ions are transported across the porous barrier to the cathode. We know the positive ions go to the cathode. And then this anode has got the methanoic acid making carbon dioxide, and the oxygen with the hydrogen ions are making water. And that's what's going on. So question 1 says the anode has acetic acid create carbon dioxide in an acidic environment. What is the half reaction for the anode? Second question says write the net redox reaction identifying the oxidizing agent and reducing agent and calculate the voltage of the cell. If the cell creates 1.50 amps of current and 3.0 grams of carbon dioxide is exhausted from the anode, what length of time did the cell function? Now, before we get further into this question, I will have to modify this in the future because I don't think you can calculate the voltage of the cell at this point. In fact, in question 4, they ask you to calculate the reduction potential for this half cell because they give you the voltage. So I'll modify that in the future. People who are looking at this in the future, you will not see that part to this question. So write the net redox reaction, identify the OA and the RA. Okay, so the first question, the anode has acetic acid create carbon dioxide. So acetic acid creates carbon dioxide. It's obviously an acidic solution because it's an acid. So what is the half reaction? Now, I've got one carbon here and I've got one carbon here. So my carbons are balanced. The next thing I do is balance my oxygens using water. I have 2 oxygens and 2 oxygens. Looking good. Then I balance my hydrogens with hydrogen ions. So here I've got 2 hydrogens, so I'm going to have 2 hydrogen ions in the products. Since this is a half reaction, I need to use electrons to balance the half reaction. If it was a net redox reaction, I can't have leftover electrons. But in this case, I'm just finding out whether it's gaining or losing electrons. Since this side has 0 charge and this has a positive 2, there must be 2 electrons to make this a net of 0 and this is a net of 0. So this is Leo, Ra. So we now know that acetic acid is the reducing agent. Since the other reactant is oxygen, that's going to be our oxidizing agent, not a surprise. Now the half reaction though that's occurring in this diagram shows oxygen and the presence of hydrogen ions. I'm going to find that in my data booklet here. So I've got oxygen plus 4 hydrogens and 4 electrons making water. So my half reaction that I'm going to have here is oxygen gas plus 4 hydrogen ions plus 4 electrons make 2 waters. And that's the GR OA, and that's at my cathode. Leo RA is at my anode. And here you can see I've got 4 electrons and 2 electrons. To balance and get a net reaction, I need to multiply this by 2. So my net reaction has 2 methanoic acids and an oxygen gas. But here I've got 4 hydrogens and I have 2 times 2, so I have 4 hydrogens in the reactants and the products. I also have 2 electrons and 4 electrons, so they also cancel each other out. And I have 2 carbon dioxide gases, we already canceled out my hydrogens, plus 2 waters. That's my net redox reaction. And we have 4 mole of electrons transferred for every 2 mole of this, 2 mole of this, and 2 mole of this, and 1 mole of oxygen. So the next question says, write the net redox reaction, identify the oxidizing agent, reducing agent. This is the oxidizing agent. These are the oxidizing agents. This is the reducing agent. Already done that. if the cell creates 1.50 amps of current and 3.0 grams of carbon dioxide is exhausted from the anode, what length of time did this cell function? So this is a cell stoichiometry question, and I've organized that information on this sheet. So I've got 1.50 amps of current, Faraday's constant, and this is in your data booklet. I have the mass of oxygen and the molar mass of carbon dioxide. From this, I can get the number of moles of carbon dioxide equals the mass over the molar mass. So it's 3.00 gram divided by 44.01 gram per mole. And that's going to give me the number of moles of carbon dioxide. So this is 0.06817 mole of carbon dioxide. But my carbon dioxide, so you'll notice I've just used the half reaction. I'm not using the doubled up. I'm just using the half reaction that I had before. For every 1 carbon dioxide is 2 moles of electrons. So the number of moles of electrons is going to be 0.06817 mole, because that was my electrons. That gets rid of electrons of carbon dioxides, right? Because that's what this was. And I want electrons. I get 2 electrons for 1 carbon dioxide, right? 2 electrons for every 1 carbon dioxide. So I'm going to take this number times 2 divided by 1, gives me 0.1363 mole of electrons. Now, the number of moles of electrons equals the current times time divided by Faraday's constant. I'm wanting to identify time, so I'm going to rearrange this. The time equals the number of moles of electrons times Faraday's constant divided by current. And that's going to give me the 0.1363 mole times Faraday's constant of 9.65 times 10 to the 4 coulomb per mole of electrons divided by the current of 1.50 amp. And if I stick that in my calculator, I'm going to come out with 8,770 seconds-ish. I think I may have rounded off a little bit, but to 3 sig digs, this should be fine. Now, if I take that number, I can convert that time to minutes. So there are 60 minutes per second, or 60 seconds per minute. So I take this divided by 60, and I come out with 146 minutes. There are 60 minutes in an hour, so if I divide that by 60, I get 2.44 hours. Now, you won't need to do it in those steps, but the answer could be in seconds, minutes, or hours. Because this was a short answer question, you don't know what you were supposed to calculate for, but unit awareness on the diploma will make it so that you can be on top of that.